Hi, I'm Maria Howard, K-8 Math Specialist, Educational Therapist, and today I'm going to teach you how to play the staircase game. The staircase game is a great game for building number sense, thinking about place value, also thinking about where a digit is placed, different places, I'm saying places a lot, affects the value of a number. So let's talk about the game board because it's kind of important. So these are two game boards side by side. I just drew them so I could show you more easily what the gameplay looks like. But this could obviously present a lot of challenge for students to draw on their own. So you can either Google staircase game board, or you can just draw these out for them. You can have them draw them, but anticipate that this might be challenging for younger students. Not necessarily a bad challenge though, because look at it. The other thing, and I actually made a mistake when drawing it, your highest set of columns, your highest column is going to be in the ones column, and then their numbers are gonna get larger and larger and larger till you have a number in the thousands, 10,000s column, 10,000s. This game is all about place value, like I said, so this is gonna be important that it's positioned this way. I recently had a student had it positioned completely the wrong way, and he didn't understand the game. And I learned a lot about his lack of understanding about place value. So that's really the whole focus of this game. So you have your 9-sided die. It doesn't have 0 to 9, 10-sided die. It doesn't have to be 0 to 9 if you only have 1 through 6, like the usual 1 through 6-sided die. This just allows you to kind of have a little bit more flexibility and more opportunities with different digits. So the way the gameplay works is you roll, one person rolls the die the first turn. Both people are going to put that number into their top row. So I rolled a 0, so both people in this game are going to get a 0, 0. So right now we have tied because look, there's nowhere else for this number to go. We have the same number. And these are conversations I have regarding sort of the place value and number sense. As we go, we're going to just discuss it. We always have to discuss it. Then we're going to roll a 3. So now we have some choice. I'm going to have it so that student 1 puts the 3 in the tens column and student 2 puts the 3 in the ones column. And this, depending on what the next roll is going to really impact place value. So there's a certain amount of risk here, and students start to get better and better as you play about thinking, you know what, most likely the number is going to be bigger, statistically speaking, bigger than 3, but let's see. It's a 4. So you can see here already, if I was with my student, I would say, it looks like I'm winning by about 10 more, right? Because 43 is about 10 more than 34. So I know I'm winning by about 10. Again, those are the conversations you could have. The next number is a 2, and if students are sort of catching on by now, I'm not saying that they will, but you might say, hey, I'm going to put my 2 in the ones column, and your student follows suit. The reason why is 2 is a really small number. I want just 2 ones, not 2 hundreds. I have a chance here to get a really big number, but it depends on what I have in the hundreds, right? Just conversations like that. I rolled another 2. So let's say that both of us decide, let's just put 2 in the 10. So right now we both have 22. And again, good point to make, no matter what the next number is, we're going to have the same number. So let's see, 5. So our numbers are almost exactly the same. That means our sum is going to be almost exactly the same, except for I'm going to have 10 more here. So I'm winning still by about 10. Actually, technically it's 9. This is what the conversation should be like when you play this game. All right, the next one's a 3, which is a bummer. This actually might work out for the student to have that 3 there, but let's see. The next number is 6. Let's say my student is not taking any chances. They're going to put their 6 in the thousands column, and I put mine in the hundreds column. Again, I'm really struggling with the orientation here. Let's see. 5. 6,500 versus something 1,600. Let's see. 2. All right. Yes. So this risk on the part of player one has paid off, because now their number is about, see, we're estimating here, about 4,000 more than my number. So they're actually winning now by a lot. But there's a whole other row, and it goes in the 10,000th place. All right, so this number is a 9. Now, if a kid understands place value, they're going to put that 9 in the 10,000th place here. So let's pretend that we both get place value. So we both have, again, I'm struggling with the mirroring. So we both have 90-something thousand, which is pretty great. 5, all right, I'm going to put my 5 here. I've learned my lesson. They're going to put their 5 here. So I put my 5 in the thousands column. They're taking another risk and putting the 5 here. Let's see what happens. And obviously the probability is going to change if you do a 1 through 6-sided die, meaning 5 is actually pretty high with a 6-sided die. All right, so I put the 2s in the 1s column, and I just rolled another 9, so that risk paid off again for my student. So they have 99,500, and I have 95,900. So you can see here already, the game is pretty much done. This person is going to win by several thousand at this point. Looks like 4,000, 8,000 maybe. And this is the estimation that we're going to make. Let's just finish this up. 8 and 8. Before the student adds it, and they always figure out that they're going to have to add the 2 numbers. Before the student adds it, we can even say, okay, estimate about how much you're going to win by. So if this is about 4,000 more and this is about 4,000 more, that means they're going to win by about 8,000. But we want to do the math just to check. So pause while I do the addition. All right, so I've done all the math, well, all the addition, and I've added the 2 numbers together. And if you see here, I've got 99,200 is my final score. My student's final score is actually 106,000, maybe round up to 107,000. So we had estimated that maybe that theirs was likely to be about 8,000 more than mine. And actually that's pretty close. If you round 106 up to 107, you keep 99,000 at 99, 107 and 99,000. The difference is about 8,000. So it's a pretty good estimation. I like this game for lots of reasons. Like I said, place value. There's some addition practice in here. There's definitely some estimation work and estimation in context. You're really estimating to find kind of like where you are in the game, like who's going to win and by how much. And I think that makes estimation a little bit more real than just telling kids estimate and then find the right answer. So it kind of adds a lot of different skills together, and it's usually pretty fun to play. All right, that's the staircase game, and I'll see you soon. Bye.